In this video, I'm going to show you a couple of examples of working the margin of error formula. My question asks about the last 18 houses sold in a neighborhood. We're given a mean and a population standard deviation, and we're asked to calculate the margin of error using a 95% and 99% confidence interval. We're going to assume our data is normally distributed. The fact that we're being asked to use the z-table is a hint we can use the normal distribution. So that means our formula is going to be margin of error is z of alpha divided by 2 multiplied by standard deviation divided by square root of n, our sample size. I can plug in my standard deviation. It's given in the question as 30. And my sample size is given as 18. Next, I want to figure out what this z of alpha divided by 2 is. Alpha is just 1 minus the confidence interval. So I'm going to work question 1 first with a 95% confidence interval. 1 minus 0.95 is 0.05. So I can plug that in for alpha, 0.05 divided by 2. And 0.05 divided by 2 is just 0.025. So now I've got z at 0.025. So the question is, how do we find the z at 0.025? What this is asking us to do, I have a normal distribution with a tau area of 0.025. So I need to find the z-score that's right here. That's going to be this part of the formula. Well, the z-table I'm going to use gives us values up to this z. So I actually want to look up this area in the z-table. Area under the curve is 1. So if my tau is 0.025, then this area must be 1 minus 0.025 equals 0.975. So I'm going to bring up my z-table and look up an area of 0.975. Here's my z-table. It's showing I'm looking up this area here. 0.975 is going to be in the center of the z-table. So I need to scroll down. 975 is right here. 0.975 has a z-score of 1.96. So now I can substitute in 1.96. And when I figure this out on a calculator, I get 13.86. This is the margin of error for the 95% confidence interval. Now for a 99% confidence interval, we're going to use the same formula with the same population standard deviation and sample size. The only thing that's going to change is this z of alpha divided by 2. So for part 2, a 99% confidence interval, our margin of error is going to be z at alpha. 1 minus 0.99 gives us an alpha of 0.01. 0.01 divided by 2 is 0.005. And this time I'm looking up an area of 0.005. That's this tau area. So what I'm actually going to look up in the z-table is 1 minus 0.005, which is 0.995. Now 0.995 is going to be in the center. This is close, 0.9949. I can either use this or 0.9951. This has a z-score of 2.57. And figuring out on a calculator, I get 18.17.